Hey everyone. So in the previous video we talked about hydrocarbons which have only carbon and hydrogen atoms, and we saw that they have two categories: the saturated hydrocarbons, which are also known as alkanes, and the unsaturated ones, which are also known as alkenes. Now I'm kinda overpronouncing these words because they have only one difference. Alkanes have A-N-E-S in the end and alkenes have E-N-E-S in the end. So alkanes have no carbon-carbon double bond, only single bonds connecting the carbon atoms, and alkenes have one carbon-carbon double bond. Now one means there could be more, but within O-level chemistry you'll encounter only one carbon-carbon double bond within one structure. So one more thing was important, that alkanes have more hydrogen atoms compared to a similar alkene. So for example, if you have a 3 carbon alkane and a 3 carbon alkene, the alkane will have more hydrogen atoms, and that is why we call it saturated, because it has more hydrogen atoms, kind of at the limit, just about at the limit. Alkenes have less hydrogen atoms, that's why we call them unsaturated. So coming back, in today's video we're going to be talking about an idea of homologous series. Now the word homologous series means that it is a family, or you can say a group of organic compounds. It's a family or a group of organic compounds that have a general formula. We'll see what the word general formula means. So they'll have a general formula, and their physical properties gradually change, and their physical properties gradually change. To understand the meaning of the concept of homologous series, we'll come back to the concept of alkanes and alkenes. And once we know what alkanes and alkenes fully are, only then we'll be able to understand the concept of homologous series. Let's try out. Let's come back to the concept of alkanes and alkenes. I'm gonna be underlining the ending of these words again, just to give us an idea that these are alkanes and alkenes, and this is the difference. For example, I am drawing 1 carbon alkane, 2 carbon alkane with two carbon atoms, a 3 carbon alkane with 3 carbons, all connected by single covalent bonds, a 4 carbon alkane connected by 4 carbons, all with single covalent bonds. I want to draw alkenes as well. So I know 1 carbon alkene isn't possible. I can't draw 1 carbon alkene. You know why? Because 1 carbon alkene isn't possible, as it needs a carbon to carbon double bond. So I cannot be having a single carbon alkene because I need a carbon carbon double bond. How will I have it? But I can have 2 carbon alkene. So I have 2 carbons which are connected by a double bond. I can be having a 3 carbon alkene with 3 carbons and at least 1 double bond. I can be having 4 carbon alkene with 4 carbons and at least 1 double bond. And I could go even further. 5 carbon alkene over here, and 5 carbon alkene on this side of the diagram with 1 carbon carbon double bond. I'm gonna fill in the hydrogens. You know how I'll do it? I know that each carbon makes 4 bonds. So my first alkane is making 4 bonds. I'm done. My second alkane is making 3 bonds with hydrogens. The other carbon also makes 3 bonds with hydrogens because they are done with 1 bond at least. For example, my 3 carbon alkane, it makes 4 bonds for each carbon. Now you'll see, if each carbon is done making 1 bond, you make 3 more. If it has made 2 bonds, you make 2 more. Let's pick some other color, orange. This carbon makes 3 more bonds with hydrogen atoms. The ones in the center make 2 more bonds with the hydrogen. The one in the corner again makes 3 more bonds with the hydrogen atoms. Let's pick some other color for the 5 carbon alkane. Let's go with this kind of pink color. I don't know. It makes, again, hydrogen atoms like this are arranged with single covalent bonds. So each time you have to just make sure that carbon is making 4 bonds, no more, no less. Now you can see a pattern over here, and the pattern is, I'm going to be zooming out a little, and you can see a pattern. A pattern is that the chain length is always increasing. 1 carbon, then 2 carbon, then 3 carbons, then 4 carbon atoms, but within the same pattern, you see, and then 5 carbon atoms. The overall pattern remains the same, that each carbon is connected by the other carbon through a single covalent bond, just the length of the chain is increasing. And with that, obviously, you get more carbon and more hydrogen atoms. So if I'm writing their chemical formula, I know that the first one has a chemical formula of C and H4. I know the second one has C with a 2. There are 2 carbons and there are 6 hydrogens. I can see that there is 3 carbon atoms in the third alkane and overall 8 hydrogen atoms. In the fourth one it is 4 carbon atoms and 10 hydrogen atoms. In the fifth one 5 carbon atoms and 12 hydrogen atoms. Each time the number of carbon is increasing by 1 and you are getting 2 new hydrogens. So each time you're getting 1 carbon and 2 hydrogen more. Similarly, if I focus on the alkenes, I'll see something similar going on over there. So for that I'll draw my structure with hydrogens fully. I know that if a carbon has made 2 more bonds, then it should be getting 2 more, just to fulfill the requirement of 10. This makes 3 hydrogens, but over here I make only 1, and over here I make 2, just to fulfill the requirement of 4. I'll pick the same orange color. I don't know which one that was, but let it be. It makes 3 bonds. This one makes 2 more. This one makes 1 more. This one makes 2 more. And the one that pink, I guess this one, yeah, same. So it makes 3 bonds. This one makes 2 more with the hydrogen. This one does the same. This has already made 3 bonds, so it gets 1. This gets 2 more. Yeah. If I focus on the fact that again the length of the chain is increasing, this time let's use some other color. A 2 carbon alkene, a 3 carbon alkene, a 4 carbon alkene, a 5 carbon alkene. At the end of the day, you see that the overall pattern is still the same, just the length of the carbon chain is increasing. If I write the chemical formulas over here, this one is C2H4. This one is C3H6. This one is C4H8. I'll put it a little at a distance. C4H8. This one is C5H10. You see, every time the length of the carbon is increasing, you are getting 2 new hydrogens, and these are called homologous series because they have a whole family of organic compounds which have the same kind of chemical structure. I'm not saying exactly same because there are different number of carbon and hydrogen, but they have gradually changing physical properties. So this over here, this entire structure is the alkane homologous series. This one over here is known as methane. Meth in organic chemistry means 1 carbon, so it's a methane, it's a 1 carbon alkane. The other one is ethane. Eth means 2 carbons and ane means alkane. The third one is propane. Prop means 3 carbons and ane means alkane. The other one over here, the 4 carbon one, is a butane. I'll just put these structures at a distance. I'll just move them a little bit lower. Over here, yeah, that seems fine. This one is butane. Butane means 4 carbon, but means 4 carbon, and ane means alkane. The one over here is a pentane. Pent means 5 carbons and ane means alkane. Similarly, for alkenes you will have a same pattern. For example, a 2 carbon alkene would be known as ethene. Eth again means 2 carbons, but this time it's not ethane, it's ethene. So it's a 2 carbon alkene. We have a propene, which means 3 carbon alkene. Prop means 3 carbon, remember, and then ene means alkene. A butene means a 4 carbon alkene, and a pentene means a 5 carbon alkene. So you will have homologous series which have a name that implies the number of carbon, and the ending of the name implies which homologous series does it belong to. So alkane and alkene have their own homologous series, and each member shows at least 1 carbon and 2 added hydrogens.